Good morning, everyone. Welcome back. It's Monday, 18th May 2020, Year 2 Maths. Today we're going to be comparing lengths. Right, let's remind ourselves how many centimeters are there in 1 meter. That's right, 100 centimeters equals 1 meter. Right, pause the video and make sure you have your workbook and a pencil. Please download the worksheet from either class charts or email that we have sent you. Write the short date at the top of the page, 18.5.20. Please write the LI to compare lengths. Once you have finished your work, please send a photo of your work at year2@grange.harrow.sch.uk. Let's go through the key vocabulary first. Please repeat after me. Measure, meters, M for meters, centimeters, cm for centimeters, height, length, equal or same as, greater than, less than, long, longer, longest, tall, taller, tallest, short, shorter, shortest. We're going to be using when we compare lengths, we use symbols, or we might write down the words on there comparing lengths on there. So in this case, we're going to have greater than. This is the symbol for greater than. So here we've got a statement, 96 meters is, we're looking on the other side, 69 meters, so it's greater than 69 meters. We're looking at less than, this is the symbol for less than. Now looking at the statement here, 80 centimeters, so look at it, centimeters is, and it's got 80 meters, so centimeters, meters. So 80 centimeters is less than 80 meters. All right, equal, we know the equal sign. The 60 meters is written in words is, and we've got 60 meters in numerals. So 60 meters is equal to 60 meters. Now when we're also comparing lengths, we either talk about whether it's shorter than, or longer than, or taller than. So in this case, the statement 96 meters is longer than 69 meters. Shorter than, so 80 centimeters is shorter than 80 meters. Now it's not equal anymore, it's same as. So 60 meters is same as 60 meters. So when you're doing your work, it depends whether you're going to be asked to write in words or to use the symbols of greater than, less than, or equal. Pause the video and please make sure you have downloaded the worksheet from either class charts or email that we have sent you, as the video is going to ask you to complete some questions. This is what the worksheet looks like. So if you have a look at question 2, you've got the symbols there, less than, greater than, or equal to compare the statements. Be careful that there's meters, centimeters here, so read it carefully. This is the second part of the worksheet. Right, let's have a look at the video.
Now we can confidently measure in centimeters and in meters. We're going to compare lengths today. But first, our flashback 4. The first one's counting in thirds. We're very good at counting in thirds, aren't we? The second one, 2 quarters. I think we know 2 quarters is equivalent to something else. That might help us. And then 2 questions from last term. And don't forget the clock. Pause the video here to have a go. How did you get on? Counting in thirds. 1/3, 2/3, 3/3, 4/3, 30. So we could get 30 pieces of pasta, put them into 4 parts, 4 equal parts, 4 groups, and then count how many is in 2 of those groups. But also, we know that 2 quarters is equivalent to 1 half. So we could split our group of 30 in half. Wonder if you did that. Did you get 15 as your answer? Number 3, how many vertices does a cone have? That's the pointy bit. How many pointy bits on a cone? 1 pointy bit. And it's easy with a cone because if you get mixed up between vertices and edges, a cone has 1 vertices and it only has 1 edge. Number 4, Ron has £1. He buys a chocolate bar for 57 pence. How much change does he get? What's our calculation here? We start off with £1 and then we spend 57 pence. I think we know that £1 is equal to 100 pennies. So we can do 100 pennies, subtract 57 pence. I'd like to have a look back at yesterday's flashback 4, because this is a very similar question to yesterday's. I wonder if you subtracted 57 from 100, or if you found the pairs of numbers that go with 57 to make 100. What was your answer? Did you get 43? And what about the clock? 9:15 or 9:15. Comparing lengths. I'm going to start off today with an image. There's not going to be any questions attached to the image. I just want you to think about what you know from looking at the image. What can you tell me from looking at this image? So there's our ant on the ruler. What can you tell me about the ant? Lots of things, yes? It's got 6 legs. That is one of the things about an ant. It's 5 centimeters long. Okay, it's going to be joined. Oh, buzzing around. A buzzy bee. What can you tell me about the bee? Yes, it's got 6 legs too. They're both insects. Got 6 legs. All insects have 6 legs. What else can you tell me? The bee is 3 centimeters. It is. The ant is longer than the bee. That's true. The bee is smaller than the ant. That's true. What about if we had 2 bees? Would they be longer than 1 ant? What about if we had 2 ants? How many bees would we need to be longer than 2 ants? What is the gap between the ant and the bee? If this were a running race, how much further in front is the bee than the ant? How many ants can we fit on our ruler? How many bees can we fit on our ruler? I said there was no question attached, but I suppose I've just asked you lots of questions about this one image. A really nice way to start comparing lengths. Pause the video here and have a go at question 1. We're going to have a quick look at equality and inequality. Equality is shown with our equal sign. Let's have a look. 3 pineapples. 3 pineapples is equal to 3 pineapples. The pineapples on the right reach higher than the pineapples on the left, but that doesn't matter, does it? Because we're interested in how many, and there are 3 pineapples on the right and 3 pineapples on the left. Some people use the same as a synonym for equals. The values are the same, 3 pineapples and 3 pineapples. However, the pineapples are not the same. I think the one on the left-hand side is a bit smaller than the others. So the pineapples are not the same, they're different pineapples. And just like that, 1 plus 1 has the same value as 2, but it is not the same as 2. We should probably say 1 plus 1 is equal to 2. Remember, the job of the equal sign is to tell you the numbers or objects on one side have the same value as the numbers or objects on the other side. Let's look at our next example. 300 this time. 300 is equal to 300. Last time we had 3 pineapples is equal to 3 pineapples. This time we've got 300 is equal to 300. And it doesn't matter which side we start with. Because both sides are equal, we can start on the right or on the left. Here's another example. 1 cube is equal to, you guessed it, 1 cube. And did you know the equal sign we use today was invented around 500 years ago by a Welshman called Robert Record. He was fed up of writing is equal to, so he used the 2 lines we use today. And he used these lines because he said, no 2 things can be more equal. And we can show that with these cubes. Look, 1 cube is equal to 1 cube. It's not about finding an answer. The equal sign just shows us that the 2 sides are equal. And there are our cubes sitting in the middle of our equal sign. What if I add some more cubes to one of the sides? No longer equal. So I need to change my symbol. This is an inequality sign. This is the greater than sign because 3 cubes are greater than 1 cube. And this is how we write it, because 3 is greater than 1. 3 is greater than 1. That's not the only solution to that question, though. 3 is greater than something, because 3 is greater than 0, and 3 is greater than 1, and 3 is greater than 2. But 3 isn't greater than 3, is it? 3 is equal to 3. I'd like to draw your attention to the pineapples at the top again. When I look at the left-hand side, I don't see 3 pineapples. I see 2 pineapples plus 1 pineapple, which is equal to 3 pineapples. I wonder if you can draw the equal sign and put things on either side that are equal, and then maybe have a go at splitting them up, like I've done. 2 pineapples plus 1 pineapple is equal to 3 pineapples. I could split up my other side of the pineapples, couldn't I? And have 2 pineapples plus 1 pineapple is equal to 1 pineapple plus 1 pineapple plus 1 pineapple. I wonder what you'll do. Pause here and have a go at questions 2 to 6. Some cars and a bus park on a street near a school. You shouldn't really park on streets near schools, should you? But there's no yellow lines here, so they're okay. A bus comes along. When the bus stops next to the cars, can you see that the length of the bus is exactly the same as the length of 2 cars? Each car is 2 meters long. I wonder show this in a bar model. 2 and 2. And we want to know what the length is altogether. So we put our brace on the top, and there's our question mark, because that's what we want to find out. Then we do our calculation. 2 and 2 is equal to 4. Or we've got 2 lots of 2, haven't we? 2 groups of 2. So we can have 2 times 2 is 4. Either way, our answer's 4. What if we had 5 cars? How long would 5 cars be? We put our brace on the top and our question mark, because we want to know how long 5 cars would be. What would our calculation be? 2 plus 2 plus 2 plus 2 plus 2 is equal to 10. Or 2 times 5 is 10. Either way, our answer is 10. What about if we want to know how long the bus is? We saw earlier that the length of the bus is equal to 2 cars. So we can swap our 2 cars in our bar diagram for 1 bus. And the bus is 4 meters long. What about a bus and a car? We put our brace over the top and our question mark, because we want to know how long a bus and a car are. What would our calculation be for this one? Pause here to have a go at question 7.
Once you have finished your work, please send a photo of your work at year2@grange.harrow.sch.uk. Thank you. Have a great weekend. Bye.